So my name is Dennis Kikemeli. So today we are going to learn exactly what is temperature. So in modern physics or in general science, the typical definition for temperature is the degree of hotness or coldness of an object. So this definition is very vulgar, but it's so basic, so that's how we use it. So the fundamental dimension of temperature are unknown. This means that the SI unit that we use for temperature is Kelvin. So Kelvin is the basic SI unit we use. So, and Kelvin is basically an approach to the measure of temperature. It does not tell us the intrinsic nature of temperature. So this led me to an analysis and a dive into the nature of temperature. This led me to the first approach we are going to use into my analysis of the nature of temperature is the principle of least action. I'm going to start there. So this is basically S is equal to mass times velocity times distance. Introduced by Pierre-Louis de Maupertuis, who was a French scientist, in 1740. Following the idea of least time by Pierre Fermat. Pierre Fermat introduced the idea of least time. This is where I get the tautochron. There's a lot of this is going to the least time. This is the tautochron curve. You can learn about that later. And then John Bernoulli principle of the fastest descent. This combining with this one give you the tautochron curve. Basically means same time. You can search that principle. So the basic idea of the least action by Pierre-Louis de Maupertuis was the farthest something travels, the greater the action. The fastest it goes, the greater the action. The more massive, the greater the action. So this is where the foundation of the quantum mechanics, the idea of Planck constant originated from this general idea. So now what we need to do in understanding temperature, we're going to find the action constant of light. This is basically least action of light. So this is basically like H, Planck's constant, which is 6.6 negative 34. So how do we get the least action of light? So least action of light, I've done a lot of analysis. I'm not going to them. I can basically give you the general concept. So the action constant of light is equal to 1 divided by this is the magnetic constant, this one is the electric constant, multiplied by resistance of light. So we know these values, the magnetic permeability of light, you can use that. The electric permittivity of light, so the values are here. I've not put the units, but you can look for the units. So now we need to find the resistance of light. It's a known value, but it is not constantly used. So to get the resistance of light in vacuum is equal to the magnetic permeability divided by the electric permittivity in vacuum. This is equal to this value here, 376.73 ohms. So now that we know the action constant of h of light, which is equal to 2.413 to the power of 14, this is where a moment of serendipity occurred during my analysis, where if you take 1, that is the inverse of the action constant of light, which is this value, multiplied by the speed of light, gives you 1.3824 to the power of negative 23. And any physicist can know that this value is equal to Boltzmann constant. So the dimension of 1 over h times the speed of light, this is the dimension, s squared divided by mass to length to the power of 3. So using the Boltzmannic law, which is the kinetic energy of an element is equal to 3 over 2. This is the Boltzmann constant multiplied by temperature. And since we know what entropy, since we know what Boltzmann constant value is equal to, this is also an unknown value, so we have proven this. We have proven Kb, which is the Boltzmann constant, which is equal to s squared divided by Kg multiplied by m raised to the power of 3. So now we need to find temperature. We know this one. This is mass multiplied by velocity squared, which is this one, this value. So we multiply. So we bring this one to this side. So to get temperature, we take this one inverse because it will be energy multiplied by K divided by the Kb. So we get this value. So finally we get temperature is equal to mass raised to the power of 2 multiplied by meter raised to the power of 5 divided by time raised to the power of 4.